Hello, my dear students. This is again Teacher Jenny guiding you on the fifth module for quarter 4 of Mathematics 7 with the topic Measures of Central Tendency for Ungrouped Data and Grouped Data. At the end of this video, you are expected to illustrate the measures of central tendency, which includes the mean, the median, and the mode of a statistical data, and calculate the measures of central tendency of ungrouped and grouped data. But before we proceed to the discussion, let us first have an activity titled A Mother's Gift. Here is the list of Eliza's savings for her mother's 40th birthday. 14 pesos, 6 pesos, 34 pesos, 20 pesos, 8 pesos, 17 pesos, and 20 pesos. Now here is the arranged Eliza's savings in increasing order. 6 pesos, 8 pesos, 14 pesos, 17 pesos, 20 pesos, 20 pesos, and 34 pesos. Now, using the given data, answer the following questions. First, what is the average daily savings of Eliza? I will give you 15 seconds. What's your answer? Very good. It's 17 pesos. Next question. On the arranged savings here, what's the middle value? What's your answer? Very good. It's 18 pesos. Next. What is the most frequent amount Eliza saved? What's your answer? You're right. It's 20 pesos because it appeared twice on the given data. These three questions here are actually the three measures of central tendency. Now, since you have answered them correctly, that means you are already using these measures in real life. You just don't know that they are the measures of central tendency. The average daily savings of Eliza is the mean of Eliza's savings, while the middle value of the arranged savings is the median of the given data. And the most frequent amount Eliza has saved is the mode of the given data. With that, I know that you're now ready to the discussion on the different measures of central tendency. But what do we mean when we say measures of central tendency? These are numbers that describe the central or typical value within a distribution of data. So these are used to represent the given data. There are three measures of central tendency. We have the mean, the median, and the mode. Let's start with the first measure. We have the mean. It is used to describe a set of data where the measures cluster or concentrate at a point. It is affected by the extreme values. All data, whether the lowest or the highest or the values at the middle or at the center are all considered in this measure of central tendency. This is why the mean is considered the most commonly used measure of central tendency. To solve for the mean, use the formula mean represented by x bar is equal to the summation of x over n, where the summation of x is the sum of the item values and n is the number of observations or items. Let's have examples. First, find the mean of the following: 3, 8, 12, 10, 6, 8, and 9. So to solve for that, let's use the formula mean is equal to the summation of x over n. The summation of x is simply the sum of all the data values. So that's 3 plus 8 plus 12 plus 10 plus 6 plus 8 plus 9. And n is simply the number of observations. So we have 1, 2, 3, 4, 5, 6, and 7. Adding those numbers, we have 56 over 7. And 56 divided by 7, that is 8. So the mean of the given value, so the mean of the given data is 8. Another example. Listed below are the first quarter grades of Catrice in her 10 subjects. Find her average grade. 92, 90, 89, 93, 95, 93, 87, 92, 89, and 90. Let's see the solution. So we have the formula, mean is equal to summation of x over n. So that is equal to the sum of all the grades of Catrice in her 10 subjects all over, because there are 10 subjects. Getting the sum of her grades, we have 910 over the number of subjects, we have 10. And 910 divided by 10, that is 91. Therefore, the average grade of Catrice in her 10 subjects is 91. Next, we have the second measure of central tendency, which is the median. It is the middle value when the data are arranged in either increasing or decreasing order. So to find for the median, you must arrange the given data in increasing or decreasing order to find or to easily find for the value which is at the middle. Now, there are two ways on how to find for the median. Those are based on the given number of observations. So if the data is odd, or if the number of observations is odd, and if the given data is even. If the data is odd, it's the observation on the place of n plus 1 over 2. But if the data is even, it's between the observations on n over 2 and n over 2 plus 1, where n is the number of observations or items. Examples. First, find the median of the following numbers: 3, 8, 12, 10, 6, 8, 9. So to find for the median, we use this formula. Now, since there are 7 observations, so we have 7 plus 1 over 2. 7 plus 1 over 2, that's 8 over 2. So it's the fourth observation. Now, to determine which one is the fourth observation, we have to arrange the numbers in increasing or decreasing order. Let's do it in increasing order. So we have 3, 6, 8, 8, 9, 10, and 12. Now, counting either from the lowest or the highest value, we have 1, 2, 3, 4. So it's 8. Or if we start from the highest, we have 1, 2, 3, 4. So again, it's 8. So this is now the fourth term. That means it's the median of the given data. Another example. Listed below are the first quarter grades of Catrice in her 13 subjects. Find the median grade. Okay, let's see. Since there are 13 subjects, we use the formula n plus 1 over 2 to find for the observation. We use the formula n plus 1 over 2. So we have 13 plus 1, that's 14 divided by 2. We have 7. So the median is the seventh observation when we arrange the data in either increasing or decreasing order. You may or may not use this formula because you can directly rearrange the data in increasing or decreasing order and then find the middle value. So we're now ready to arrange the given data in increasing order. So we have this one. Now, since we found out that it must be the seventh observation, we count either from left to right. So we have 1, 2, 3, 4, 5, 6, 7. That's from the left. So the median is 92. This is the seventh observation or the seventh term. Therefore, the median grade of Catrice is 92. Another example, find the median of the following data: 41, 36, 40, 35, 39, 42, 37, and 38. Let's see the solution. Since the given number of observation is an even number, therefore we use the formula n over 2. That's 8 over 2. So we have the fourth observation or the fourth number on the given data. But since it's even, so we have to take also the next number after the fourth observation. So we have the median between the fourth and fifth terms. Arranging those numbers in increasing order, we have 35, 36, 37, 38, 39, 40, 41, and 42. That means the fourth and the fifth terms are 38 and 39 respectively. So the median is equal to the average of those two middle values. That's 38 plus 39 over 2. So we have 77 over 2 and that's 38.5. So the median of the given numbers is 38.5. Last example. Listed below are the first quarter grades of Catrice in her 12 subjects. Find the median of her grades. Okay, let's see. We have the observation on the 12 over 2. So that's on the sixth observation. That means we're going to take the numbers on the sixth and seventh observation. Arranging the grades, we have this one. That means the sixth and seventh values are 1, 2, 3, 4, 5, 6. So we have 90 and 92. Now getting the average of those two numbers, we have median is equal to 90 plus 92 all over 2. 90 plus 92, that's 182 divided by 2. So we have 91. So the median grade of Catrice is 91. Next, we have the last measure of central tendency. We have the mode. It is the simplest measure of central tendency. It is referred to as the most frequently occurring value in a given set of data. So this time, you just have to know how many times the number appears on the given data. But before we find for the mode, let's have first the different kinds of data according to the mode. First, we have no mode. So take note, a data can have no mode, and that is when all values appear with the same number of times or frequency. From the definition of mode, it must be the most frequently appearing value in a given data. Second type, we have unimodal. From the name itself, it's unimodal if the data has only one mode. Third kind, we have multimodal. Multi means many. Therefore, a data is said to be multimodal if there are two or more modes. Now, there are two special kinds of multimodal. First, we have the bimodal. Take note, these kinds of modes are already under multimodals. Bi means two, therefore for bimodal, it's a data that has two modes. And the other special multimodal is the trimodal. Tri means three. So this is a data that has three modes. Let's have examples. First, what is the most frequently occurring number on the given set of data? We have 9, 10, and 13. There are three modes, so the kind of data according to mode of this example is, you're right, it's multimodal. To be specific, it's a trimodal. Another example, we have 3, 8, 11, 14, 17, and 23. What is the mode of the given data? Very good. The given data has no mode because all numbers appear only once. So that's no mode. Third example. Again, find the mode of the given data. We have 21 and 39. It's multimodal. To be specific, it's a bimodal. Another example. Again, find the mode of the given data. You're right. The mode is 13. So what kind of data is this? Correct. It's unimodal. One mode, so unimodal. So since we're done with the measures of central tendency for ungrouped data, let us now have the measures of central tendency for grouped data. The mean for grouped data. Now, there are two ways in finding the mean of grouped data. First is using the class mark. If you can still remember, the class mark is taken by getting the sum of the upper and lower class limits, then divide the sum by 2, or simply get the average of the limits. In here, we use the formula mean is equal to the summation of fx all over the summation of f, where f represents the frequency and x for the class mark. Let us have examples. First, find the mean of the given frequency distribution. Of course, using the class mark. So first, we have to complete the needed information in this given table. First, we have to determine the class size. To find for that, you can subtract the upper limit by the lower limit, then add 1. So that's 15 minus 11, it's 4, plus 1, so we have 5. So the class size is 5. Or you can just count the numbers included in each class interval. So say for example, for the interval 46 to 50, we have 46, 47, 48, 49, and 50. So there are 5 numbers. Next, we have the summation of f. To solve for that, we simply have to add all the numbers on the frequency column. So that's 7 plus 6 plus 9 plus 7 plus 6 plus 3 plus 0 plus 2 is 40. So the summation of f is 40. After that, we now have to complete the column for the class mark. So again, to find for the class mark, we have to add the upper and the lower limit, then divide the sum by 2. So that's 15 plus 11. It's 26 divided by 2. We have 13. For the second class interval, we have 20 plus 16. That's 36. Divided by 2, it's 18. Now, you can do that up to the highest class interval. Or, you can just add the class size to the preceding class mark. So, to find for the class mark of the class interval 21 to 25, we now have 18 plus the class size 5. So, we have 23. Plus 5, it's 28. Plus 5 is 33. Plus 5 is 38. Plus 5 is 43. Plus 5 is 48. Let us check using the highest class interval. We have 50 plus 46. That's 96 divided by 5 is 48. Now we have the column for fx, which is found by multiplying the frequency by the class mark, f times x. So we have, from the bottom, 2 times 13, that's 26. 0 times 18 is 0. 3 times 23 is 69. 6 times 28 is 168. 7 times 33 is 231. 9 times 38 is 342. 6 times 43 is 258. And 7 times 48 is 336. Now, since we have completed the fx column, we can now find for the summation of fx. So we simply have to add now the values under the fx column. So that's 336 plus 258 plus 342 plus 231 plus 168 plus 69 plus 0 plus 26. And the total is 1,430. Now, since we have completed the table, we can now compute for the mean of the given data. That is by using the formula mean is equal to summation of fx all over summation of f. By substitution, summation of fx is 1,430. It's this one. All over the summation of f, which is 40. Summation of f is here. So we have 1,430 divided by 40. That gives us 35.75. So the mean of the given data is 35.75. Another way is using the coded deviation. This simplifies calculating accurate values by hand because when compared to using the class mark, this formula will require you to solve smaller numbers. So in using the coded division, we use the formula mean is equal to AM plus the summation of FD all over summation of F times the class size, where AM is for the assumed mean, F for the frequency, D for the coded deviation from the assumed mean, and I for the class size. Let's have examples. First, find the mean of the given frequency distribution. So again, like using the class mark, we have to complete first the table. But this time, instead of the class mark, we have D for the division. And instead of Fx, we now have Fd. So like using the class mark, we have to find first for the class size. For this example, we have 5. And the total frequency is 40. Now, for the assumed mean, if you're going to select the class interval for our assumed mean, you just have to determine which interval has the highest frequency. So we have 9. Now, to find for the assumed mean, you simply have to determine the class interval with the highest frequency. So we have 9. So our assumed mean is on the class interval 36 to 40. That's our assumed mean. Now for the division, you must start from the assumed mean because it must be 0. I'll repeat, the division of the assumed mean should be 0. Going upward, we add 1. Going downward, we subtract 1. So from 0 going upward, we have 1, 2. Downwards, we have -1, -2, -3, -4, -5. And then for FD, we simply have to multiply F and D. That's F times D. So we have 7 times 2, it's 14. 6 times 1 is 6. 9 times 0 is 0. 7 times -1 is -7. 6 times -2 is -12. 3 times -3, that's -9. 0 times -4 is 0. 2 times -5 is -10. Now, since we have completed the FD column, we can now find for the summation of FD. And that is -18. Now, before we solve for the mean of the given data, we have to find first for the value of AM. The AM is the class mark of our assumed mean. So that's upper limit plus lower limit divided by 2. By substitution, we now have 40 plus 36 all over 2. And 40 plus 36 is 76 divided by 2, so we have 38. Next, we now solve for the mean of the given data by using the formula mean is equal to AM plus I times the summation of FD all over summation of F. So by substitution, AM is 38. It's from this one. Plus, we have for summation of FD, that's -18. For summation of F, we have 40. Times I, we have 5. So we have 38 plus -18 times 5, we have -90. Divided by 40 is -2.25. So we have 38 plus -2.25, that is very good, 35.75. So the mean of the given data is 35.75. Now let's have the median of grouped data. Take note, when we say median, it's the middle value of a given data. So to find for the median of a grouped data, we use the formula MD is equal to LB sub MC plus summation of F over 2 minus less than CF all over F of MC times I, where MD represents the median, LB sub MC is the lower boundary of the median class, the less than CF is the cumulative frequency of the lower class next to the median class, the F sub MC is the frequency of the median class, and I is the class size. Let's have an example. We have here the weight of students. So what we're going to do is to find for the median of this given grouped data. To do that, first we have to complete the table. Starting off with the value of the class size. If you can still remember, in finding for the class size, we simply have to subtract the upper limit minus lower limit plus 1. So that's 15 minus 11 is 4 plus 1, so we have 5. Or you can just count manually the numbers belonging in each class interval. So say for example, in the class interval 46 to 50, we have 46, 47, 48, 49, 50. There are 5 numbers included on the class interval. Therefore, the class size is 5. Now, for the total frequency or the summation of F, we simply have to add all the values under the frequency column. So that's 7 plus 6 plus 9 plus 7 plus 6 plus 3 plus 0 plus 2, and that gives us 40. Now, for the lower boundary, we simply have to use the formula LB is equal to LL minus 0.5. Or, the lower boundary is equal to the value of the lower limit minus 0.5. So, for the class interval 11 to 15, we have the lower limit 11 minus 0.5, that is 10.5. For the class interval 16 to 20, we have 16 minus 0.5, and that's 15.5. Next, we have 21 minus 0.5, that's 20.5. Or, to find for the succeeding lower boundaries, we simply have to add 5 or the value of the class size to the preceding lower boundaries. So that's 20.5 plus 5, that's 25.5. Plus 5 is 30.5, plus 5 is 35.5, plus 5 is 40.5, then plus 5, we have 45.5. Now, for the less than CF column, you may start with the class with the highest class interval. That's 46 to 50. Its less than CF value should be equal to the value of the summation of F, since it's the highest class interval. So we have 40. To find for the succeeding less than CF, we simply have to subtract the less than CF minus the frequency. So that's 40 minus 7, it's 33. 33 minus 6 is 27. Minus 9, it's 18. 18 minus 7 is 11. 11 minus 6, 5. 5 minus 3 is 2. 2 minus 0 is 2. Take note, you can check your answers on the less than CF column. That is by making sure that you have the same value on the lowest class interval for the column's frequency and less than CF. So since the frequency of the lowest class interval is 2, then the lowest value or the last value on the less than CF column should be equal to 2. Or starting from the bottom, we have to copy first the frequency of the lowest class interval, that's 2. Then to find for the succeeding less than CF, we have to add the next frequency to the preceding less than CF values. So 2 plus 0, that's 2, plus 3 is 5, plus 6 is 11, plus 7 is 18, plus 9 is 27, 27 plus 6 is 33. 33 plus 7 is 40. Now, since we've completed the table, we're now ready to find for the median class. And to find for it, we use the formula summation of f all over 2. By substitution, the summation of f is equal to 40 divided by 2, so that is equal to 20. Now, to find for the median class, you must look for the values on the less than CF column which are larger than 20. Our summation of f over 2 value. Then after that, you choose which among those values is the lowest. So for this example, we have 40, 33, and 27. These are the values on the less than CF column which are greater than our value for summation of f over 2. And the lowest among those values is 27. Therefore, the median class is on the class interval containing less than CF, which is 27. So it's on the class interval 36 to 40. Take note, this is our median class, or in symbols, we have MC. Take note, finding the median class is very important. It will help you substitute values on the formula for median. So now let's solve for the median of the given grouped data. By using the formula, MD is equal to LB sub MC plus summation of F over 2 minus less than CF all over F sub MC times I. By substitution, we have the lower boundary of the median class, that is 35.5. Then, summation of F over 2, it's here, we have 20. Minus the value of the less than CF. Take note, this should not be found on the median class. Instead, it's the value below or less than the less than CF of the median class. So it's 18. All over the frequency of the median class, which is 9. Times the class size, which is 5. So we have to simplify first. 20 minus 18, that's 2. Now, in simplifying 2 over 9 times 5, it would be better if you multiply first before you divide. Because if you divide first, and then you got an answer which is not exact, then you will have to round off. And in rounding off, there are some changes or errors on the computation. So we have to multiply first 2 times 5, that's 10. Divided by 9, so we have 1.11. So the median is equal to 35.5 plus 1.11, and that is equal to 36.61. So the median of the given grouped data is 36.61. Take note, the computed median is found on the class interval of our median class. It's between 36 to 40. Let's now proceed to the last measure of central tendency, which is the mode of grouped data. Recall that when we say mode, it's the value that occurs most often in a given data. So to find for the mode of a given grouped data, we use the formula MO is equal to LB sub MO plus D sub 1 over D sub 1 plus D sub 2 times the class size, where MO is the mode, LB sub MO is the lower boundary of the modal class, D sub 1 is the difference between the frequencies of the modal class and the next upper class, and D sub 2 is the difference between the frequencies of the modal class and the next lower class, and of course, the I is the class size. Now let's have examples. Again, we have here the examples we have used in finding the median of group data. So since we have completed the table a while back and found the values for I summation of F and LB column, let's just go through it. I is 5, summation of F is 40. Then for the lower boundary, take note, we subtract the lower limit minus 0.5. So that's 10.5 followed by 15.5, then 20.5, 25.5, 30.5, 35.5, 40.5, and 45.5. Now, find for the modal class. To do that, we simply have to look for the highest value on the frequency column. So looking at these numbers, the highest value is 9. So the modal class is the class containing that highest frequency. So we have the class with the class interval 36 to 40. So take note, this is our modal class. Or in symbol, we have MO. Now, since we've found the modal class, we're now ready to calculate for the mode. Using the formula, MO is equal to LBMO plus D sub 1 all over D sub 1 plus D sub 2 times the class size. By substitution, the lower boundary of the modal class is 35.5. It's here. Now, for D sub 1, we have to subtract the frequency of the modal class by the frequency of the next upper class. So that's D sub 1 is equal to 9 minus 6. We have 3. For D sub 2, we have to subtract the frequency of the modal class by the frequency of the next lower class. So we have 9 minus 7 equals 2. So again, for D sub 1, we have to subtract the frequency of the modal class by the frequency of the next upper class. While for D sub 2, we have to subtract the frequency of the modal class by the next lower class. So D sub 1 above, D sub 2 below. So by substitution, we now have D sub 1, that's 3. D sub 2, we have 2. And for the class size, it's 5. Simplifying, we have 3 plus 2 first, that is 5. Then multiply 3 by 5, that's 15 divided by 5, so we have 3. And 35.5, that is 38.5. Therefore, the mode of the given group's data is equal to 38.5. So that ends our discussion on the 3 measures of central tendency. But before we end this video, always remember that there are 3 measures of central tendency. First, we have the mean, which is used to describe a set of data where the measures cluster or concentrate at a point. Second is the median, which is simply the middle value when the data are arranged in either increasing or decreasing order. And of course, we have the mode, which is referred to as the most frequently occurring value in a given set of data. And there are 3 kinds of data according to the mode. We have the no mode. For one mode, it's unimodal. For 2 or more modes, we have the multimodal. And there are special types of multimodals. We have the bimodal for 2 modes and trimodal for 3 modes. This ends our topic. I hope you have learned a lot from this video. Thank you for watching.